Today we will learn about the derivative of the implicit functions. But before that, we need to learn what are the two forms of functions. So on the left, we have what we call as explicit functions, where y is explicitly shown in terms of x. So here in this equation, we have y is equivalent to 2x plus 1. So y is expressed directly in terms of x. While here, we have what we call as an implicit form, where we have the equation x minus 2y is equals to 18. We don't know what is the value of y yet. Unlike with this one, y is equivalent directly to 2x plus 1. So we can easily convert this one in terms of a function form. F of x is equals to 2x plus 1. There you go. We now have the functional form of our y. Well, in this side of the equation, we have x minus 2y is equals to 18. You need to do mathematical arrangement, algebra to this one, in order for you to showcase what is the value of y. So this is what we call as an implicit form. So the function could be expressed in explicit, and the function could be displayed as an implicit. So here at implicit forms, you need to decipher first what is the value of y. So normally, what we're going to do is to isolate y on the left side of the equation and transpose all of the other terms on the right side or left side. It depends upon you which side you'd like to form or would like to see what is the value of y. So in this type of example, I could transpose my 18 to this side of the equation and transpose my negative 2y to this side of the equation, which will give me x minus 18 is equals to 2y. And now I can divide both sides with 2. So I have now converted this implicit form into an explicit form of y, which is y is equals to x minus 18 divided with 2. So this is the explicit form of this implicit x minus 2y equals to 18. So I could now convert this one in terms of function. F of x is equals to x minus 18 over 2. Okay, so similarly in this example, xy is equals to 1. I could also do the same process. We have dividing both sides with x so that I can isolate my y. So this is now equivalent to y equals to 1 over x. Now this could be converted now in terms of a function. F of x is equals to 1 over x. So I have then converted this implicit form xy is equals to 1 into a function form explicit. F of x is 1 over x. Now how about this example? So obviously this is an equation of a circle with radius of 5. So I'm going to isolate my y on the left side of the equation, transposing my x squared. So I now have y squared is equals to 25 minus x squared. Now to come up with the only value y in this side of the equation, I have to apply square root on both sides of the equation. So I now have y as the square root of 25 minus x squared. I can then convert this one into f of x is equals to the square root of 25 minus x squared. Now we know and now we learned how to convert an implicit form into an explicit form just like this one. So all we need to do is do some algebraic manipulations and we can now have their functions. Now let's go to our topic. We're going to find dy over dx of this implicit form. X squared minus 2y cubed plus 4y is equals to 2. Apparently, this type of function x squared minus 2y cubed plus 4y equals to 2 is no longer the same as what we have previously, because this particular example has y cubed and y on this side of the equation. We cannot easily find the value of y. So if we try to isolate y on this side of the equation or transpose this one to the other side, I could have x squared transposing 2 minus 2 is equals to transposing this one to the other side, 2y cubed minus 4y. I would say that I can factor out my y. So obviously we can factor out y and we can factor out 2. So on this side of the equation, x squared minus 2 is equals to 2y, and then we have, factoring out 2y here, we now have y squared, and factoring 2y here, we have 2, and we would say that I'm going to find the value of this y right here, so I'm going to divide both sides with 2y squared minus 2 with 2y squared minus 2. So I now have my y on this side of the equation, y. And on this side of the equation, I have x squared minus 2 over 2y squared minus 2. So apparently, although we have found out a value of y right here on this side of the equation, but on this side of the equation, we still have another y right here. So this has not been converted into an explicit form because we still have a y in this side of the equation. Our goal in converting an implicit to an explicit form is vividly shown, clearly shown, what is the value of y on this side of the equation in terms of x, in terms of x, in terms of x, in terms of x, in terms of x. Now on this side of the equation, we don't know the exact value of specific y right here. So how are we going to find the derivative of dy over dx of this implicit function? How are we going to find the dy over dx? Okay, so we come up with this process, the derivative or the implicit differentiation. So for the implicit differentiation, we have to follow these 4 steps. Please try to take screenshots so that you can review this one later. So the first step is to differentiate both sides of the equation with respect to x. No more transposition, no more alteration of the equation. All you need to do is to differentiate both sides of the equation with respect to x. Meaning to say, you're going to apply d over dx to your equation. So when we say equation, it is an algebraic expression that has an equal symbol in it. So if you have d over dx to your y equals to, let's erase this one, y squared plus 18 minus x squared equals to 2. So you're going to apply this derivative operator to all the terms in this equation. This is an equation. Okay, so that's the first part. Differentiate both sides of the equation with respect to x. We will be differentiating the left side and the right side of the equation with respect to x. Even though we have y right here, even though we have x right here, all we need to do is to differentiate this one with respect to x. Next, we're going to collect all the terms involving dy over dx on the left side of the equation and move all the other terms to the right side of the equation, simply isolating terms with dy over dx on the other side of the equation. The third, we have to factor dy over dx out of the left side of the equation. And fourth, we're going to solve for dy over dx. But before we will proceed to the process, let's try to apply this first process. Differentiate both sides of the equation with respect to x. What does it mean when we say differentiating with respect to x? Okay. Differentiating with respect to x. We all learn how to differentiate directly a function with respect to our variable. So right here, this is the operator of the derivative with respect to the x here written below. So if we're going to derive x with respect to x, this is clearly equivalent to dx over dx. Numerator times our function divided with the denominator, that is dx over dx, which is basically equals to 1. Normally, we don't write this one directly. The derivative of x is directly equivalent to 1. But to give us a clear process and a clear view to this one, I wrote it in this manner. So d over dx of x, that is dx over dx, which is basically equals to 1. Okay, that is an identity rule. Next, if you're going to differentiate from the power rule, so the derivative with respect to x of x cubed, so obviously we have a power x cubed right here. So the derivative of this one, applying derivative to x cubed, that is equivalent to the power rule. We write the constant in front of our variable or our function, 3x raised to the power of 3 minus 1. And then afterwards, since this is x, so we write the derivative of x with respect to x. So this is what is actually happening in the power rule. So in the power rule, aside from applying manipulation on the power, we also need to derive what is the variable. So as you can see, the variable x is coinciding or is agreeing with what is the variable we need to derive to. So that is why we have to multiply dx over dx. When we say dx over dx, that is equivalent to 1. Therefore, 3x squared times 1, it's still 3x squared. We simply write the derivative of x cubed as equivalent to 3x squared. But this is what actually is happening right here. Okay? We apply power rule. There is this still chain process into our variable, but this example clearly states that our variable is coinciding with what is the variable we're going to derive to. But what if we now have two variables just like this one? So if we're going to derive with respect to x a variable y, so we're going to derive a certain variable that is not agreeing with the variable that we are going to derive to, that is simply equivalent to dy over dx. See, writing the numerator d times y over dx. So that will be equivalent to dy over dx. Okay? When we say dy over dx, that is the notation of the derivative of the function. So when we see dy over dx, that is basically the derivative of the function. Because it is also known as y prime or f prime of x. Notice dy over dx, that is the form of derivative of the function, or that is f prime of x, or that is y prime of x, or that is the slope. Okay? So, recalling, if we're going to apply derivative to y is equals to 2x, we are applying derivative to all of the sides of the equation. So the derivative of y with respect to x, that is dy over dx right here. The derivative of 2x with respect to x, that is 2 dx over dx, which is 1. So dy over dx right here, from this simple equation, that is equivalent to 2. Constant multiple, copy 2, derive x. Copying the 2, the derivative of x is 1, so that is why the dy over dx is equals to 2. Furthermore, if we have this equation, y is equals to x cubed plus 1, simply applying derivative operation to this one, the derivative of this side of the equation, dy over dx, that will become dy over dx. The derivative of x cubed plus 1 with respect to x, since this one is agreeing, so this is power rule, 3x squared. The derivative of 1 is 0. So that is why we no longer write 0 right here. Okay? So this is an example of applying derivative operator to our equation. This is an equation. We have an equal symbol, and then we have our explicit form of the function right here. Also, at this side, we have an equation right here, enclosed in the parenthesis, and this is our operator, d over dx. That is why we have come up with the answer. And also this one, we have come up with the answer. So if it agrees, then that is equivalent to 1. The derivative with respect to x of x, that is 1. If it does not agree, d over dx of y, that is dy over dx. Derivative with respect to x of w, does it agree or not? Not. So that is equivalent to dw over dx. If we have the derivative with respect to x of v, that is dv over dx. Clear? Okay. Now, if we have the derivative with respect to x of 2y, so we're going to derive this function 2y that is equivalent to a constant multiple rule. So when we say constant multiple rule, we're going to copy the 2 and then derive the variable y. So since these two does not agree with each other, so that is why we have the derivative of y, which is dy over dx. Now, if we're going to elevate this with this type of example, the derivative with respect to x of a y cube. Clearly, this is a power rule. Because we have a variable y raised to the power of 3. Now, if we're going to derive this one using the power rule, we bring down the 3, copy the variable y, and subtract 1 to our exponent. But we're not yet done right here. Again, we're actually going to apply a chain rule into this one. So, chain rule is what we're going to use if the variables does not agree. So here, the variable x is not agreeing with the variable y. So if we're going to apply derivative to this one, we are not just only going to use power rule, but also we're going to multiply the derivative of our variable, which is dy over dx. So notice we have to apply chain rule if we have two variables does not agree with each other. So applying chain rule to this one, since we already derived this one, we've already come up with the power rule to this one, then we're going to derive the variable y. The derivative of y is dy over dx. So that's the process in finding or differentiating a variable with respect to x. Now let's have more examples so that we can identify directly the derivative of an implicit form. Here we have x plus 3y. So this one is agreeing with respect to x, and this one is not agreeing because these two are two different variables. So this is an example of a sum and difference rule. So there are two functions or two terms added together, x plus 3y. So applying derivative to x and also applying derivative to 3y. This one is agreeing, so that is why that is equivalent to dx over dx, which is 1. This one is a constant multiple rule, 3, and then the derivative of y, which is dy over dx. So we now come up with the result, 1 plus 3 dy over dx. That is the derivative with respect to x of x plus 3y. Now if we have this one, x times y, that is clearly a product rule with respect to x, again with respect to x. So meaning this x is agreeing to this x is not agreeing to this y. So if we're going to apply product rule, we come up with this process, copying x, derivative of y with respect to x, that is why we have dy over dx, plus copy y, the derivative of x with respect to x is dx over dx, or equivalent to 1. So we now have x dy over dx plus y times 1, or that is equivalent to x dy over dx plus basically equivalent to y. Again, from this perspective, that is a product rule. And obviously, x is agreeing, that is just equivalent to 1, and y is disagreeing, that is why it is equivalent to dy over dx, right here. Now let's elevate it more. If we have this example, okay, the derivative with respect to x of 2xy cubed. So we have a multiple of 2, so we can write 2 in front, and we're going to apply this derivative only to our variables, only to the xy cubed. Okay, so we've isolated 2 outside because that is a constant multiple rule. When we say constant multiple rule, we just copy the constant and derive the function. This is our function, this is our constant. So we better write it in this manner to have a clearer view on what we're going to do next. So notice this is a product rule. Copy x. This is now the 2 isolated 2 outside, and we have a bracket so that we can visualize this one clearly. So copy x, derivative of y cubed, so chain rule, 3y, 3 minus 1 times the derivative of y with respect to x, plus copy y cubed, the derivative of x with respect to x, which is 1. So we now come up with this. So we arrange this one, 3, copying 3, x, and then we have y squared, and do not forget we still have the dy over dx, plus we have the y cubed left right here because this is just 1. So now that we have derived the function inside our bracket, we now multiply the 2. Multiplying 2 or distributing 2, we now have 6xy squared dy over dx plus y cubed. Okay, so this is the clearer view. Having learned that, now we are ready to find the derivative of this implicit form, x squared minus 2y cubed plus 4y equals to 2. Again, we need to follow this process. Step 1, differentiate both sides of the equation with respect to x. 2, collect all the terms involving dy over dx on the left side of the equation and move all the other terms to the right side of the equation. 3, factor out on the left side of the equation the dy over dx and solve for dy over dx. Okay, start with this one. Find dy over dx of x squared minus 2y cubed plus 4y equals to 2. So having learned from the step 1, we don't need to rearrange, we don't need to transpose, and we don't need to alter this equation any longer. All we need to do is apply the derivative with respect to x into our implicit form of the equation. So as you can see, we have how many terms? 1, 2, 3, 4 terms in our equation. And what are the variables that agree with this one? We have x, it agrees. This term we have y. We're going to use constant multiple and chain rule to this one. Here we have another y and another constant multiple, and just find the derivative of y, which is dy over dx. Then we have 2, the derivative of 2 is 0. Okay, let's check. Okay, so we have right here, this one is power rule. Since it agrees, that is just apply basic power rule to x, the derivative of x with respect to x, which is 1, minus constant multiple rule, copy to the derivative of y cubed, that is chain rule. So we now have 3y squared times the derivative of y with respect to x. So that is why we now have dy over dx right here. Plus, copy 4, the derivative of y, which is still dy over dx, and the derivative of 2 with respect to the variable x is 0. That is a constant. Simplifying, we now have 2x minus 6y squared dy over dx plus 4 dy over dx is equated to 0. Now the question is, what step are we going to do next? Step number 2, collecting all the terms involving dy over dx on the left side of the equation. So which has dy over dx? The terms that has dy over dx. So we have negative 6y squared and 4. This 2 has dy over dx. So what shall we do with 2x? We transpose it to the other side of the equation. We will left the left side of the equation only with the terms that has dy over dx. So arranging, I have this one. So I have arranged this one so that I have a positive value. So I wrote 4 dy over dx first, minus 6y squared dy over dx is equals to, transposing this one 2x, that will become negative 2x. So I'm done with step number 2. Let's go proceed with step number 3, factor out dy over dx. So this 2 equation has dy over dx. I'm going to factor that one out. I now have dy over dx right here. Factoring dy over dx in this term, what's left? 4. Factoring dy over dx in this term, what's left? Negative 6y squared is still equals to negative 2. What's next? Solve for dy over dx. So I'm going to isolate, and I'm going to remain dy over dx on the left side of the equation. So to remain dy over dx right here, I'm going to divide both sides with this type of algebraic expression. Dividing both sides with 4 minus 6y squared, and also the other side of the equation, 4 minus 6y squared, meaning to say I am canceling this one. So that is now equivalent to dy over dx as negative 2x over 4 minus 6y squared. Okay, so that is our result. Now how about this type of example? Find dy over dx of the implicit function. We have an equation of a circle. So this circle has x squared plus y squared is equals to 25. Find dy over dx of this function. Okay, so from what we have learned from the steps, we don't need to rearrange anymore, converting this one into an explicit form. So an implicit, all we need to do is to find the derivative with respect to x. Apply the derivative with respect to x to our equation. No more alteration. So this one is a power rule. This one is a chain rule. This one is a constant. Applying this one as agreeing. So that is the derivative of x squared is 2x plus the derivative of y squared, that is 2y. But since it is disagreeing with this x, so we now have dy over dx. And the derivative of 25 is 0. Now, what the step tells us, okay, to remain or to write dy over dx on this side of the equation and transpose this one to the other side. So that is why we have this one. 2y dy over dx equals to negative 2x. Now the goal is to find dy over dx. We need to get rid of 2y. So we divide both sides with 2y. Divide both sides with 2y. So now we have dy over dx. Our goal, finding dy over dx as equivalent to negative x over y. So this is our final answer. But if you're going to ask, is it really the same if you're going to solve it in an implicit differentiation rather than in explicit form? So if you happen to convert this one into explicit, since you can easily convert this one. Okay, so we have this convert to explicit. So x squared plus y squared is equals to 25. So we have y squared is equals to 25 minus x squared. Okay, so taking the square root on both sides, y as the square root of 25 minus x squared. And rewriting square root, that is y as quantity 25 minus x squared, quantity raised to the power of 1/2. So we can now find the derivative. Okay, so applying chain rule. So y is dy over dx is now equals to chain rule. We have 1/2 quantity 25 minus x squared, 1/2 minus 1, that is negative 1/2, times the derivative of the inside, the derivative of g of x. 25 is 0, minus, we have minus the derivative of x squared, we have 2x. Notice this is multiplication, everything is multiplication. 2 divided by 2 is cancelled out. So we now have dy over dx as rewriting this one on the front, negative x. Then we have our quantity 25 minus x squared raised to the power of negative 1/2. Since this is negative 1/2, we're going to write it below. So we have dy over dx as negative x over square root of 25 minus y squared. So this is now the dy over dx. And it is equivalent to negative x over the square root of 25 minus x squared. Clearly, it's different from here. This one is dy over dx is negative square root of negative x over y. So does that mean that this one is incorrect? Does this mean that implicit differentiation is incorrect because it is not the same with explicit? Okay, so we need to make these two equal. How to make these two equal? Remember that when we say square root of 25 minus x squared, that is equivalent to y. So have you seen this one? Square root of 25 minus x squared, that is equivalent to y. Therefore, this could be written as dy over dx as negative x over y. And that is the same with our answer at the implicit solution. So notice our two solutions, the implicit differentiation and then the differentiation that what we learned from the previous chapter. So notice they would arrive with the same result. So please observe and notice that we can solve it via implicit and solve it via explicit.